Right now, on a high ridge in the Bkaya Valley of Lebanon, three blocks of limestone sit perfectly integrated into the foundation of a classical temple complex. These are not standard architectural units. They are physical anomalies that push the absolute boundaries of ancient logistics. Each block in this trio, historically known as the trilithon, weighs an estimated 800 to 1,000 metric tons. To visualize this mass clearly, a single stone in this wall weighs significantly more than 10 fully grown blue whales combined, or roughly 3 fully loaded commercial passenger jets. According to official survey documentation published by institutions like the German Archaeological Institute, these blocks represent some of the heaviest quarried objects ever moved and elevated by human agency in antiquity. But the true mystery that stops structural engineers cold is not merely their weight, it is their placement. These blocks were not simply dragged along flat terrain, they were lifted approximately 7 meters, or over 20 feet, above the ground level of the surrounding bedrock. They were then fitted together with such extreme precision that modern researchers note the joints lack any mortar, yet show a clearance of less than a millimeter. The standard historical narrative found in standard educational textbooks asserts a singular conclusion. The Roman Empire engineered this platform during the 1st century before Common Era. However, when we cross-examine this assertion with the known mechanical limits of classical Roman crane systems, documented by the Archaeological Institute of America, a deep mathematical gap emerges. The maximum recorded capacity of Rome's most advanced heavy lifting device, the multi-pulley polyspastos, maxed out at approximately 100 metric tons under ideal laboratory conditions. How does a civilization operating with a documented 100-ton physical ceiling lift and align a single 1,000-ton block without leaving a single architectural blueprint or written record explaining the feat? Today, we step beyond the brief descriptions of tour guides to examine the raw geological data, institutional excavation reports, and the silent evidence hidden in the stone itself. Baalbek, known to the Greco-Roman world as Heliopolis, the city of the sun, sits roughly 3,000 feet above sea level. Archaeological strata compiled by organizations such as UNESCO demonstrate that this sacred hilltop has experienced continuous human occupation for at least 11,000 years. The visible architectural marvels above ground are undeniably Roman. Beginning around 16 before Common Era, under the reign of Augustus Caesar, Roman architects initiated the construction of the grandest religious sanctuary in the entire empire. The Temple of Jupiter Heliopolitanus was designed on a scale that exceeded the Parthenon in Athens. Its 6 remaining monumental columns still reach 65 feet into the sky, displaying the unmistakable beauty of imperial Roman craftsmanship. Nearby, the Temple of Bacchus remains one of the most perfectly preserved examples of classical Roman architecture in existence today. Mainstream history books rightly celebrate these structures as triumphs of Roman willpower and organization. Yet when field excavators look closely at the massive podium beneath the Temple of Jupiter, the architectural continuity changes abruptly. The Roman temple does not form the base of the site. Rather, it sits directly on top of an existing prehistoric stone platform. This lower platform is constructed from megaliths so enormous that they make the highly advanced Roman masonry above them look relatively standard in comparison.
The Romans were among the most meticulous record keepers of the ancient world. They documented the logistics of their aqueducts, the financial costs of their roads, and the engineering behind their colosseums in thousands of surviving texts. Yet, in all of Roman literature, architectural manuals, and imperial inscriptions, there is complete silence regarding the moving of the trilithon stones. Not a single imperial decree, architect's journal, or commemorative stone tablet claims credit for quarrying or moving these 3 foundational giants. This total absence of documentation raises a critical question for modern researchers. Did the Romans actually build this foundational podium? Or did they simply discover an existing monument and choose it as the sacred anchor for their own temples? To find the answer to this riddle, investigators must look outside the temple walls and travel roughly 1 mile to the local limestone quarry. It is here that the ancient project was abruptly halted, leaving behind a literal crime scene in stone. Inside this quarry sit several unfinished monoliths that were fully shaped but never transported to the main site. Intriguingly, these abandoned blocks are even larger than the ones successfully placed beneath the Temple of Jupiter. The most famous of these quarry blocks is the Hajar al-Hibla, or the Stone of the Pregnant Woman, which weighs an estimated 1,000 to 1,200 metric tons. It remains partially attached to the limestone bedrock at a distinct angle, as if the stonemasons suddenly dropped their tools in the middle of a workday and never returned. For decades, public documentaries claimed this was the absolute largest quarried stone block on Earth. However, in 2014, a highly controlled scientific excavation conducted by the German Archaeological Institute uncovered an even more monumental truth. Buried directly beneath the Hajar al-Hibla, hidden under centuries of topsoil, researchers discovered a completely forgotten stone block. Laser measurements and volume calculations established its mass at an astonishing 1,650 metric tons. This discovery completely redefined our understanding of ancient quarrying capabilities, making it officially the largest single block carved by human hands ever found on Earth. The stone was perfectly squared off, smoothed, and fully prepared for transport across the valley. What catastrophic event or historical disruption could have caused a civilization capable of carving a 1,650-ton block to instantly abandon their grandest ambition? Some peer-reviewed studies published in the Journal of Archaeological Science suggest that major seismic disruptions or sudden regional conflicts may have shattered the societal structure of the builders. Whatever the cause, the quarry proves that the builders of Baalbek had plans that were never completed. Plans engineered on a scale that challenges our modern assumptions about the linear progress of human history. When we evaluate the practical theories proposed by mainstream engineering history, we must look directly at the mathematics of friction, tensile strength, and material hardness. The primary hypothesis taught in academic courses involves the use of wooden rollers, hemp ropes, and immense teams of laborers. This methodology was undoubtedly successful for moving 50-ton to 100-ton blocks in ancient Egypt and Mesopotamia, as verified by experimental archaeology. However, when applied to a 900-ton or 1,200-ton block, the basic physics of materials begin to break down completely. At these extreme pressures, the immense weight concentrated on wooden logs exceeds the crushing strength of the timber fibers, causing the rollers to splinter into dust. Furthermore, the tensile strength of ancient organic ropes has a clear mathematical limit. To pull a 900-ton block up the natural incline from the quarry to the temple would require ropes so thick they could not be effectively pulled by human hands. One independent engineering analysis calculated that moving just one of the trilithon stones using basic human muscle would require a synchronized force of over 40,000 workers. Logistically, placing 40,000 people around a single stone block in a narrow valley without them trampling each other is a near impossible task. If we look at the alternative theory of Roman machinery, the problem only deepens. The Romans always utilized a specific tool called a luis, drilling small standardized holes into stones so that iron lifting keys could clamp onto the block. Every verified Roman block at Baalbek features these distinct markings. Yet the giant trilithon stones contain absolutely no Lewis holes or crane clamp scars anywhere on their surfaces. Beyond the weight, the extreme precision of the stonework introduces a geological paradox. The local limestone rates between 3 and 4 on the Mohs scale of mineral hardness. While Roman iron chisels could certainly carve this material, researchers have documented microscopic uniform lines running continuously along the joints between the giant blocks. These parallel markings are spaced with a precision that some independent researchers argue is difficult to achieve via irregular manual hand hammering. Additionally, the site contains the shattered remnants of roughly 200 rose granite columns. Geological analysis confirms this specific granite was quarried in Aswan, Egypt, more than 700 miles away. To reach Baalbek, these exceptionally hard stones, rating 6 to 7 on the Mohs scale, had to be transported across the Mediterranean Sea and hauled over the steep Mount Lebanon range, which peaks at over 8,000 feet. Shaping, smoothing, and polishing imported granite to a flawless finish implies an extraordinary mastery of abrasive materials and logistics that requires deeper investigation by academic institutions. Baalbek does not exist in a historical vacuum. When we step back and look at the broader geographic record of our planet, we discover a striking, highly precise pattern of megalithic architecture. At the fortress of Sacsayhuaman in the Peruvian Andes, massive stone walls are assembled using interlocking multi-angled polygonal blocks. Just like the platform in Lebanon, these Peruvian stones fit together perfectly without any mortar, surviving centuries of intense seismic activity. In China, the ancient Yangshan quarry contains an unfinished monument estimated to weigh over 16,000 tons, displaying parallel tool marks that mirror the quarry techniques seen in the Bekaa Valley. These sites are separated by thousands of miles of open ocean, and according to standard timelines, were built by completely disconnected cultures centuries apart. Yet they all share the exact same engineering ambition, utilizing the maximum possible tonnage and matching it with geometric precision. Furthermore, we must consider the factor of advanced astronomical alignment. Surveys archived by organizations like the National Geographic Society show that the foundational platform of Baalbek is oriented with remarkable accuracy toward the cardinal directions. Its specific structural corners track the precise path of the sun during the summer and winter solstices. This exact same commitment to embedding celestial mechanics into giant stone foundations appears at the Giza Plateau in Egypt, at Stonehenge in England, and at Teotihuacan in Mexico. These alignments were clearly not accidental or merely decorative choices. They suggest that whoever engineered these foundational platforms possessed a highly sophisticated understanding of the cosmos and mathematics long before the advent of modern astronomical instruments. What does all of this physical evidence truly mean for the timeline of human history? Mainstream archaeological consensus maintains that these megaliths are the product of early historical periods, constructed either by Hellenistic architects or by the Romans through sheer numbers and undocumented engineering innovations. Alternative interpretations presented by independent investigators suggest that these ancient platforms might be the remnants of an older, highly advanced pre-cataclysmic culture that was largely lost to time. Intellectual honesty requires us to realize that both hypotheses currently contain unresolved scientific gaps. The strength of genuine archaeological inquiry lies not in defending a rigid conclusion, but in having the courage to look at the physical evidence objectively. Our ancestors were clearly not primitive societies stumbling blindly in the dark. They operated with an advanced understanding of geometry, materials, and mass that we are only now beginning to fully decode. The massive stones of Baalbek remain firmly in place, silently refusing to fit neatly into the simple narratives of our textbooks. The buried chambers recently detected beneath the platform by ground-penetrating radar remain largely unexcavated, waiting for future generations of scientists to discover their contents. The open question of who built the foundation of Baalbek remains one of the most compelling mysteries of the ancient world. If you value a careful, fact-based investigation into the anomalies of our shared past, take a moment to interact with this content. Who do you believe shaped and placed the monumental Trilithon stones? Was it an unrecorded triumph of classical Roman willpower? Or is it the legacy of a forgotten chapter of human history? Share your logical analysis in the comments below. Every week, we continue to look closely at the places where physical field data and official records invite deeper questions. Until next time, stay safe, keep analyzing the data, and never stop exploring the truth.